Hello everyone. Let us discuss about diffraction and Young's double slit experiment. Diffraction. What is this? Diffraction of light is the phenomena which takes place when it passes through a narrow slit or any edge of the obstacle. Okay, what it happens? It bends the light. Okay, it bends the light and also it spreads the light. Yeah, so this is known as diffraction. So in Young's double slit model, Young's double slit model or experiment, what we observed previously, we have known that light is made up of photons and it is a particle nature. But in this experiment we found that light has wave nature. Suppose let us take a cupboard here. We made a slit here parallelly, very narrow slit. Okay, and it is very close to each other. Then suppose this is a screen. What we are supposed to observe, if we have source here, source of light here, the light, it will go here and it will passes through this slit and will form two bright lines here, isn't it? It was supposed to observe this way. Clear? But in this experiment we had observed some other thing, some other pattern, like in between of this line parallelly we'll have one bright light, and then dark, bright, dark, bright, dark, bright, dark, this way. These are in a fringe manner. Fringe manner. So how it happens? Since we know that light travels through a straight line, so we should have only two lines of bright marks. Clear? But we got many bright and many dark fringes. Why it happens? Okay, let us discuss this one. Is it the light goes in a waveform and then it what interference here? Is it the way or some other thing? Yes, this is the interference of light. Okay, when the two sources, the wave comes out from the two sources superimposed, then interference takes place. If it is constructive interference, then we'll have bright fringe, and if it is destructive, we will have dark fringe. Clear? Clear? Okay. Now, as our source was in this manner, let us rotate it and make it in this manner so that we get the fringes horizontally. No, I mean to say vertically. Okay, vertically, dark, bright, dark, bright, dark, bright. These are two slits, and you can consider this as source 1, source 2, separated by the distance d. You'll have one screen here which is very far. Okay, suppose the distance between the screen and the source is d. This is screen, and here small d is very smaller than capital D. Okay, clear now? So in this middle point, you can consider this as point P, and here the source 1 will produce light here and here. Yeah. So here you can see S1P equal to S2P. There is no part difference. Is there any part difference? There is no part difference. Clear? No part difference. So you will have here a central bright fringe. Central bright. You can consider it as central bright. Yeah. Okay. Huh. Now let us see consider what the position where you will have bright fringes and also the position where you will have dark fringes. It's raining heavily. Okay. Yeah. See here, we can consider a sine theta del x by d. Okay, since this was sine theta del x by d, so del x we can write d sine theta. Okay, this is the part difference. Okay, now let us consider bright fringes. For bright fringe, for bright fringe, you will have part difference n lambda, where n is 0, 1, 2, 3, 4, 5, 6. Okay, clear now? So suppose this is the point. Now this is the point P. Source 1 and source 2. Okay. This is angle theta. The part difference, what you will find? The part difference is, if we draw a perpendicular here, you will have here part difference. This is the part difference. This is del x. And this is 90 degree. This is 90 degree. So this will be 90 minus theta. If this is minus 90 minus theta, this will be theta. Have you understood? Here you see this is very far. So you can consider that the S1P is equal to S2P. S1P is equal to S2P. They are almost parallel. Okay, because this is very very small. Okay, this D should be in millimeter, and this one should be in, this D should be in meter. Yeah. Okay. For first bright. Okay, this was the central bright. Then you'll have, suppose this is the first bright. For first bright, you'll have n equal to 1. So del x equal to theta, isn't it? Del x equal to theta. Okay, let me write here. Huh? So I was having sine theta equal to del x by d. So here del x is theta, theta by d, sine theta. And here you see it's very very small. So in this case we can consider sine theta as tan theta. We can write in place of sine theta tan theta. Not in all cases, but in 99% cases we can write, since this is very small. Okay, these are very small. So sine theta, tan theta is what? Tan theta is perpendicular by base, isn't it? Perpendicular by base. And in this triangle, what you will find? Perpendicular. Which one is perpendicular? Perpendicular, you can consider this y. Okay. So y, and base is this one d. Since this is tan theta, y by d, small d. So y you will have del d by del this d by small d. So this is the first position. Okay, first bright. And in case of second bright, what we will do? We will consider here 2. What 2? Which one 2? And 2. So 2 lambda, it will be 2 lambda. So here you will replace 2 lambda. You will have here 2 lambda. You will have here 2 lambda, you'll have your 2 lambda. Okay. And for third, what you'll consider 3 lambda, 4 lambda for 4, 5 lambda for 5. Okay. So, okay, this is for 2 lambda now. So second bright, yeah, second bright. I'm not consider I'm not considering these as first bright. This is central bright. This one is first bright, second bright, third bright. In between you'll have dark. Okay. Now let us do for dark. In place of dark, you'll have del x equal to del x is how much? 2n minus 1 lambda by 2. Or you can directly consider like what you'll have. You'll have lambda equal to del x equal to it's not visible, I guess. Oh, sorry, this is not visible. No? So only this one. This was visible, huh? This was visible. Only this one. So here you was having 1 lambda, 2 lambda, 3 lambda, 4 lambda. Okay, in case of bright fringe. But in case of dark fringe, you will have del x equal to lambda by 2. Then you will have 3 lambda by 2. Then you have 5 lambda by 2. Then you have 6 lambda by 2. Because the formula was 2n minus 1 lambda by 2. Put here 1. So 2 minus 1 is 3. I mean, it's a 1 lambda by 2. 2 to the 4, 4 minus 1 is 3, 3 by lambda by 2. Got it now? N is 1, 2, 3, 4 this way, okay? Clear? So now what you need to change? You need to change this one. Now we are doing for destructive interference. Okay, destructive. That means dark fringes. Dark fringes. Suppose you consider del x as first dark fringes. For first dark fringes, you'll have lambda by 2. So here lambda by 2. You'll have lambda by 2. You'll have your lambda by 2. You'll have your lambda by 2. This is the first dark fringes. For second dark fringes, you'll have your 3 lambda by 2, 3 lambda by 2. You'll have your 3 lambda by 2. You'll have your 3 lambda by 2 for second dark fringes. Okay. For third also, you'll have 5 lambda by 2d, 5 lambda by 2d. Clear, clear. So, what is the general formula for dark fringes? Let me clear this. Look, for bright fringe, or this is also known as maxima, you will have the general formula will be lambda d by d and lambda d by d. Okay, n is 1, 2, 3, 4, anything. Means it depends upon the first bright, second bright, third bright. And then for dark fringe, which is minima, you can consider the formula 2n minus 1 lambda d by d. Here you have 1, 2. Did you understand this one? Okay, I got it from this. If you understood, then okay, we'll proceed. Clear na? So dark fringes and what? Bright fringes. Okay, dark fringes, bright fringes, dark fringes, bright fringes. Okay, we will now proceed further. Now fringe width. It is also considered beta, or sometimes it is also considered as W. See, for bright fringe, what we had the formula and lambda d by d. For dark you had 2n minus 1 lambda d by 2d. Okay, and the diagram was this way. This was the central bright. Here you will have first bright, second bright. Here down also first bright, second bright. In between you will have first dark, second dark, first dark, second dark. See, understand very nicely. Okay, see, from central here from here you have to measure, na? I mean to say, um, the bandwidth. What is this bandwidth? This is bandwidth. Oh, fringe, yeah, fringe width. Okay. See, the consecutive two bright fringes will make the fringe width of a dark fringe. Got it now? The consecutive distance between two consecutive dark is the width of bright. Clear? How you see here? This is the central one from first bright to second bright. See here. This is first bright. First bright I was having lambda d by d, and second I was having 2 lambda d by d. What is the difference between this? This minus this. You'll have lambda d by d. Clear? And in case of dark, I was having the formula 2n minus 1 lambda d by 2d, and for second I was having this was the general formula. So if I put here 1, 2 minus 1, so d lambda by 2d, and here I will have 3 lambda d by 2d for second minima. So if I subtract this, I'll have how much? I'll have 2 lambda d by 2d, 2 cancels out, then I'll have lambda d by d, which is of same. So the fringe width is same between two consecutive bright fringes and between two consecutive dark fringes. So remember, the fringe width is same, and that is lambda d by d. This is the fringe width. Have you understood this one? Now let us consider intensity. Let us consider the intensity. Okay. Okay. So assume, what will you assume? You have to assume source 1 and source 2 is having same intensity, I1 and I2, but they are of same intensity as I. Here, so relative intensity will be I1 plus I2 equal, not equal to, minus twice I1 I2 cos phi. This is what? This is phase difference. Did you understand? Oh, here it will be plus. Huh? Since this is same, so I plus I twice I 2. This is also same, so I square and root over cancels out. So you will have only one I cos theta. You can take common twice I 1 plus cos not theta phi, and you can uh, you can have this formula. This is this one. I can consider this as this. So this I can write 2I 1 plus 1 plus 2 cos theta can be written as cos square theta. Got it? Got it now? What I'm saying? No, no, 1 plus 2 cos theta. So it can be written as cos 2 cos square theta. 2 cos square theta. And this 2 you can multiply here. 4i cos square theta. See, this is the general formula of intensity. Now, for maxima and for minima, what will happen? Look, for maxima, you can consider the phase difference as 0. If phase difference is 0, then cos theta will or cos phi will become cos 0. Cos 0 is 1. So you'll have 4i. So for maxima, that is of bright range, you'll have intensity 4i. And for minima, what you need to do? You need to consider this as 0 so that this becomes 0. So you take means you have phase difference phase difference of 180 degree. Correct? Phase difference of 180 degree. So cos 180 degree is 0. So this whole term will be 0. So here the intensity will be 0. Correct? Oh, this was for this one. Oh, yeah. Clear now? So if I draw a graph between the intensity and the what part difference, what you'll have? Suppose this is intensity already written. This is part difference here 0, pi, here pi by 2, then pi, then 3 pi by 2, then 2 pi. Here also same pi by 2, pi, 3 pi by 2, then twice pi. It goes on now 5 pi by 2. Okay. So when I was having maxima, suppose this is 4. When I was having maxima, I was having 4. When I was having minima and dark range, I was having 0. So this is minima, this is maxima, this is minima, this is maxima, this is minima, this is maxima, maxima 4, this is minima, this is maxima. So here I will have of this type. Correct? That means how the fringe will appear completely bright and then it goes to 0, that is minima, and then completely dark and then completely bright, completely dark. This way the fringe will be visible. Okay, clear? Got it? Because 4 intensity 4 and then it goes on to 0 and then 4 again goes on to 0 again 4 again goes to 0. Now what are the condition of having a distinct interference? Condition of having a distinct interference. See, there are 5 conditions. Let me discuss one by one. As I have mentioned in the diagram, that D should be very, 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 very smaller than D. Clear? D is very, very smaller than D. This is the first condition. Second condition, the source should be monochromatic. Okay, you have to use a single light source. single color source, clear now. And then uh, what is that called? Uh, uh, what was that? Coherent, and then coherent source, your coherent light. How you'll have this coherent light? You will use only one source. No, I mean to say you'll have both slits, but you can use one source here, one source, so that you put here one convex mirror. It splits here. How it was? Yeah, yeah. Obviously, this was like this. Clear now? So S1, S2. Look, the frequency is totally depend upon the source. Frequency is totally depend upon the source, but the wavelength may change due to the medium. So you should have coherent source. That means the phase difference should be constant. Okay, with respect to time, the phase difference should be constant. Clear na? So you should have coherent source. You should have monochromatic source, and then the distance between the two slits should be very small than the distance between the screen and the source. Clear? And then you should have amplitude of both the sources should be uh, should be should be near to be equal. Okay, near to equal. Look, because look, I'll explain this. For bright fringes, that is maxima, and for dark fringes, that is minima. Here a1 minus a2, and here amplitude, it adds up. Amplitude adds up. So if I have one, source two, both sources, here amplitude one is 100, here amplitude one is 10. So here what I will have, both, if I sum up I will have 110, and if I take the difference I'll have 90. So here you see the amplitudes are nearly same. You cannot observe here completely dark and completely bright. But if you have nearer, the source are nearer, like this is 100, and then this is, suppose you have 110 or 90, then you'll have here 190 if I add up both, and if I minus it out, I'll have 10. See here, the source, I'm going to say here the amplitude is much greater than this one. That means this is completely bright and this is completely dark. Is this visible or it is too low? Okay, I'll write above. Suppose this is 100, amplitude of source 1 is 100, and then here also 100. This is equal. So here you will have 200, and here you will have 0. See here, completely bright and completely dark. Got it now? So this amplitude should be equal or nearer to equal. Frequency of both lights should be equal. Huh? Number 5. Frequency of both must be equal. F1 equal to F2. Okay. So this was a short video on this one, Young's double slit model or experiment. If you have any question, you can ask me in my comment section. Thank you.